with Jim, PB, and J, and then just our project SketchSpace. My name is Jim Kim. I'm graduating this semester, and I've accepted an offer from Samsung Austin.
I'm Connor Flynn. I'm graduating next May. I do not have a job.
I'm Andrew Daniels. I'm graduating this semester, and I have accepted an offer at General Motors in Austin.
And I'm Kyle Kirkenbauer. I'm graduating next Friday, and I've accepted a position in Dallas at Busy and Team. So a little bit about our project. We focus on cognitive maps, which are a person's spatial understanding of their area around them. And spatial cognition is how a person gathers that data. And as you can see here, we have an example of someone's cognitive map of the campus. So you can see they've outlined some of the buildings and labeled important ones to them. The way I like to illustrate this idea to people is, say you had a friend coming to town who's never been there before. You're going to draw all the landmarks that you deem important on the way in so they can find their way. So the idea of our project is we want to create a web application that's going to create a way for instructors to gather a classroom's worth of mental maps and analyze the data and trends amongst them. So here we have an example of our UI, the create assignment. We have assignment name and description. And then here we have the ability for them to upload an image of, say, here we use a Google Maps of my hometown actually. And we can outline the buildings to use as a template and a reference when we're comparing trends amongst the students. So why is this needed? Obviously, manual collection of paper mental maps is obsolete at this point with our new tool. And comparisons analysis can be made much easier online. These can also provide reflecting patterns in personal experience, where they spend a lot of their time, where they eat is a trend that we find very interesting. They're going to know the path from the dorms to visa if they live on campus pretty well. And also, SketchSpace allows instructors to distribute a URL to their students. They don't need an account. They can submit anonymous submissions that allow for collection, but we can't relate any of that personal information to the student. Prior technologies that have to do with cognitive mapping. So the Spatial Intelligence Learning Center offers a couple of multiple choice quizzes online that have to do with judging your spatial intelligence. They give you a score, percentage score. Jenny Wade did research on children ages 6 to 18. Mainly, she had them draw a dog. And at age 6, they draw a dog with 2 legs and a 2-dimensional plane. As they get older, they start to draw the dog with 4 legs, like this, the 2D representation. And then as they get older, like the dog in motion, things like that. And then You Are Here Maps is a GPS system. And I don't know about you, but when I'm in my car and I'm GPSing to somewhere I've never been before, I'll get there and come back, and the next time I have to go there, I have to GPS it again, because I wasn't paying attention on the road. Or, I mean, I was, but more GPS. And so You Are Here Maps illustrates landmarks to you as you pass them, so that you can start to make relationships in your mind.
Okay, so some of the challenges that we faced with this project. The first one was maintaining anonymity. We wanted to collect personal information so that we could, in the future attribute these personal traits, to aspects of the map. Get some interesting data, but we didn't want to collect, too personal or too much information. Also grading, through talking with our mentor, who we'll talk about later, we determined that, correct or exact distances and exact scales weren't as important as exactly identifying what they drew, as well as like contributing that to the map and their personal aspects. So overlapping structures was something, or a problem we faced. We solved that by using Paper.js, which allowed us to track individual strokes, and we're able to attribute those strokes to themselves and won't be lost if there's other strokes overlapping. And the last one's rotation. Everyone has a different idea or orientation of their map in their head, it seems like. Like some people may draw maps with true north. There's Aggieland North, which is more towards Northgate, that it could be oriented. Some people may draw it completely upside down. So we had to account for all of that, which we were able to do, but it also, in the future, if we were to do analysis, it would make orientation of buildings and individual objects very difficult. So impact on the world. SketchSpace will make it very easy for instructors to collect all these mental maps and have them in one place, rather than having a bunch of paper, having to write down attributes of each one and be able to just go online and see it. So this will help to further understand how cognitive skills develop. You could use the same test for the same person and give it to them once a year and see how their map changes. It also provides very insightful data. It's very unique how people observe the world. Trying to see that through other people's eyes, like this is one of the few ways you can do that. So us as a team, we're all computer science majors, taking a variety of classes, but our mentor, he's a professor here in the Department of Geography. He gave us a lot of insightful data because he's worked with mental maps before, cognitive maps. He helped us understand that the exact dimensions and scales aren't too important versus what do they identify and what's very important on the map to them. Also, we talked to a professor, Devna Butner. She works here in the Department of English, and she wrote a paper over how cognitive maps can be drawn just by reading about a place. So you're reading a book. It's a fictional place, but you're developing this map in your head. So this could be a very interesting aspect of, if she gave it to her students, what would they draw of, some, say, like Westeros and Game of Thrones or something. So just a few ethical concerns. Once again, how much information do we want to collect? There's no accounts, so we weren't attributing that to anyone individually, but also in the future, you could almost determine, personal aspects of people based off their mental map. Like, if they drew like one location very well, you could determine, they probably hang out there a lot, and is it ethical for us to, make that analysis of someone? And then in the future, is it okay to attribute a grade to someone's map or analyze it like that aspect? Because, it is personal, it works for them, so.
So in order to implement our idea, we used a variety of different tools. We developed on CentOS, and we primarily used Django, which is a Python web framework, and that was integrated with a PostgreSQL database. And then our application was served using an Apache web server. For the front end, we used JavaScript, like a lot of websites, and we also used the Django HTML language in order to generate the HTML pages. And then for the front end, we also used Paper.js in order to track the stroke, or in order to track the strokes of the users when they're drawing, but we'll talk about more of that later. And this project was too big for just one person to tackle individually, so we decided to break it up and collaborate. And for that, we used GitHub.
Right, so I did most of the software, which was a lot of the Paper.js, the strokes, how we label the strokes and how we do that mapping, how we pass that mapping around so it doesn't get lost, and then store it in the database, get it out. We still have that mapping of strokes, the labels, and we can give that to the instructor.
And I designed a lot of the website in terms of how you can navigate between the different pages. When you're the instructor, what information is displayed, where can you go from the website?
My official title is Researcher User Study Architect, which basically means I take the feedback we get and make sure that's being implemented with our mentor and from our user studies. And I also help work on some of the HTML, CSS.
And then I'm with the database operations, storing the path data as byte data in the Postgres, and also storing all the information about questionnaires and classes that teachers instruct.
And for the architecture of our design, it starts in the top right with the instructor. Nothing can really happen without the instructor using our application. From the instructor, they're allowed, when they visit our website, they're allowed to create an account, because when an instructor creates an assignment, they want to be able to later go and view those details. So that data needs to be persistent and tied to an account. When you create a particular assignment, it generates a URL, and that's how you can give it to your students. And from this URL, when you access it, you're not required to log in or create an account or anything. Like we mentioned earlier, in order to remain anonymous and have anonymous data. Once the student completes their account or completes their sketch, it's submitted into the database along with questionnaire information, and that can later be used by the instructor in order to evaluate all the submissions. And here's a demo of our application. When you come to the site, you can register, create an account, and just username and password to keep it simple. And once you log in, you're free to create your assignment, because this is a new account, there's no assignments associated with it. The assignment name and the description is pretty valuable in terms of, that's the description when the student goes to take the assignment, what gets displayed. Here we upload a campus map, so then as the instructor can create an assignment, they have some template to sort of base their drawings off of. And when that's how they label a specific structure. When they create the assignment, this is the URL that they can give to their students, and that allows you to navigate around. So then in this demo, we're also going to complete the assignment. You come in, it has the description at the top, which for this is just video description. You can draw, and then you can proceed to the next step, which is labeling your drawing. And then those labels get pulled from the assignment that the instructor created. And then here is where you would do the questionnaire. And for user-centered design, we had to decide how we wanted the users to be able to sketch with our application. Like we mentioned earlier, accuracy wasn't as important as, because we didn't want the students to be able to create a very detailed sketch. So we just gave them simple tools. Like Paint, you're just able to sketch, and we used Paper.js to accomplish this because it allows you to collect the stroke data. Rather than just storing just the image that they draw, we wanted to be able to, in the database, make it more specific in terms of storing individual sketches, so that later, with analysis, we have more to work with.
So with the help of our mentor, Dr. Ritz, we were able to put our web application into one of the classes, the Intro to Geography class. And so with that, we received over 70 submissions and counting. And these submissions they're easily available to the instructor to view right now. And also on top of that, out of the 70 submissions, we received about 50 questionnaires at the end. And so the questionnaire, essentially from a 1 to 5 scale for a lot of the questions, asked how easy it was to draw a mental map or a cognitive map, and how easy it was to label that map, and then how easy it was to access our website, and the sense of direction and mathematics skill. And so in the picture is an example of what a instructor would view if they went to your assignment.
And when they click any of these different links to view the submission, it will pull up the student's sketch along with what they labeled.
And so another thing was comparing between the use of a tablet and a keyboard and mouse. So when you're using a tablet, it's a lot easier to draw. It's more natural in a sense, more like a pen and paper. And so users were more inclined to draw more if they felt it was easier. But if you're using a keyboard and mouse, a lot of users, when they drew their item or their buildings, it was kind of difficult to do so. So after like drawing certain buildings, they would just stop drawing. And then also cognitive maps are a lot different, are different between person to person. And so our data, we wanted to see how easy it would be to create the assignments using our application, and also how easy it was to draw this cognitive map using our application and then label it too. And so to do that, we asked them the questionnaire, and also we stored all their data regarding the drawings itself. And so for the questionnaire, we had we'll say we have 46 for this one. And so about 73% said that they were able to draw their mental map easy. And this would probably increase if they used a tablet, because a lot of these were being done with a keyboard and mouse. And then about 75% said that they were able to label their cognitive map easily. And also, because this was hosted on the TAMU network, some people had difficulties using a VPN or being on campus to actually assess the assignment. And so we had about 80% saying they had no issues accessing the assignment. And so for future works, currently we don't grade or analyze the data we have, but we could possibly in the future grade against the template that the instructor creates, or create like a heat map for maybe where users draw the most, like where they go most, and because they probably know when they draw, they probably know the area the best where they go to. And also using, we don't allow users to label their own buildings at the moment, so allowing them to label their own buildings with like specific names, so we would need to then parse that name to fit into the database in a specific manner. And then also doing a 3D SketchSpace rather than doing a flat plane would be some future things. And so, in conclusion, we created an application to make research more efficient, essentially, for instructors, and also gathering data from students in a more efficient manner, and to automate that. And thanks, and good. Any questions?
So I'm still curious as to, I guess, good job first off, interesting. But I'm curious as to why the instructor in a biology class is going to care about this, right? Is it really geared toward, I got the Westeros reference, like that show too. But I get it, and if it's a literary work and you're trying to see if people are maybe creating the same mental map that the author intended, but is it really purposed for that area, or are there purposes for this outside of that area?
I think it was definitely geared towards geography and spatial awareness, as well as, like, we didn't even think about the English aspect until we stumbled upon a paper she had written. So I think it is geared towards more of those areas, but I definitely think there's probably other things out there we could do with it.
So in your scan of the literature at the beginning of this, did you find where other disciplines out other than geography or literature are using this in creative ways that this could have play in?
Right.
Well, one of the most important things is, like I mentioned earlier, for development, mental maps are very personal, and from what we've seen, they vary very significantly between different people. So in terms of tracking use over time and how a student, or if a kid is growing up in a city, drawing the mental map of their city, as they grow older, they have access to more places, and you can see how the mental map grows as they grow. That's one case it could be used in.
Yeah, I also think, like, in the future, like, we would like to do analysis to see what areas they draw better, and I think can also be like more useful outside of geography, because like maybe the campus could make an assignment and be like, hey, everyone draw a mental map of main campus, and they could see what attributes students recognize the most, or like what is the most important to students at the time.
I think how many students in which major attend football games with these statistics you could probably pull from cognitive mapping. Also think there's definitely psychology and probably anthropology applications.
So how are the drawings persisted in the database? Which format they are stored in?
Each of the strokes is decomposed back into a byte array, and then each of the strokes that the user draws will be stored as its own table, and then it's also stored. There's another component of whether or not the user labeled that drawing. What more are you interested in?
So you're not saving the drawings in as images or anything?
No, they're not. They're not stored as images. They're composed of all the different strokes.
So each individual stroke is just a vector of points, and we store that essentially as byte data in Postgres.
More like SVG kind of thing.
Right. And all those if they did label them, then it will be mapped to a label as well in the database, so that we know whenever we redraw that stroke for the instructor that it's going to have this label. Eventually, that will also help with analysis by, all these are these labels, but the ones they didn't label, we can almost attribute it to like, okay, it's this distance from each of the labels in the template. In their drawing, it's a similar distance from each of those. So we can almost do some machine learning and hopefully map on living buildings in the future.
Yeah, that's the reason actually I was asking, like, eventually you will get to that analysis part where you
Right.
probably have to compare the images and all of that, the drawings.
Exactly.
So then, obviously, the format that you are using is a better fit, I think.